Chemical reactions. There are many types of chemical reactions. We're going to learn about the basic form that all chemical reactions take, how we view them as chemists, and 5 of the main types of chemical reactions. So what exactly is a chemical reaction? It is the process that creates chemical changes. If you're taking notes, write down these key point definitions. Whenever we think about chemical reactions, we need a way to represent them. Conveniently, we have elements and compounds that we've been learning about already in chemistry, and we know how to represent the number of atoms in those elements and compounds. Let's put those all together to make something called a chemical equation. A chemical equation is an expression written like a math equation that describes the changes that happen in a chemical reaction. In this example, we have a chemical equation with 2 Na, or sodium atoms, plus a chlorine molecule, Cl2. That arrow means that there's a reaction that has taken place and it creates something new. So this creates 2 NaCl molecules, or salt. There are 2 main parts to chemical reactions: the reactants, the starting materials used in the reaction. Those are on the left-hand side of the chemical equation. They're everything that's before the arrow. The products are the substances produced by the reaction. That's the new stuff that was created. So in any chemical equation, the products are on the right-hand side. They come after the arrow. Let's look at a chemical equation and break down, what does this mean? What are all of these pieces? What would it really look like? Let's draw it together. So here in this chemical reaction, I have 2 Na. We know that Na is an element. It's the element sodium. Since it's all by itself, we can draw this as just a circle to represent that atom, sodium. I happen to know that sodium forms a positive ion when it's by itself. So we have 1 sodium atom, but this chemical equation is telling me that I should have 2 of those, 2 sodium ions. Plus, the second part of this chemical equation is this chlorine. This is Cl2 with a subscript of 2. The subscript tells me that this is chemically bonded to each other. So instead of drawing 2 separate atoms like I have with the sodium, for the chlorine, I need to draw 2 circles that look like they're chemically bonded, 2 chlorines that are stuck together. There are different ways that you can represent this. Now this chemical reaction says that it is making something new. These 2 things are going to react with each other and produce 2 molecules of NaCl. So what would that look like, NaCl? So we would have our Na, our sodium, chemically bonded to chlorine. And you've seen this molecule before. You've seen it represented before. This is actually not a molecule at all. It's an ionic compound, sodium chloride. This is regular table salt. So what really happened in this chemical reaction is these sodium atoms came into contact or came near these chlorines, and this bond between the 2 chlorines broke apart and a new bond was formed. So we created something new. We broke some chemical bonds, we formed some new chemical bonds, and we got new stuff. That's why we call it a reaction. There's action, there's something happening. Something else that we commonly see in a chemical equation is the state of matter. When you're doing real chemistry or observing a reaction take place, it's really important to know, should I be looking at a solid, a liquid, a gas, or something in between? So we add the state of matter to all of the products and reactants. It's written in parentheses. So if you have a substance that is a solid, you'll see that written as a parentheses S after the species. If you have a liquid, and this means pure liquid, that's just the substance is in liquid form, it would be in the parentheses with an L. The last is a gas. If we have a gas, you guessed it, we'll have parentheses with a little g. But actually there's one more, and it's one that we see really, really often, because oftentimes in chemical reactions, we don't have just a pure liquid. We have some kind of substance, some compound or molecule that's dissolved in water. And that can be important to consider in chemistry, is if it's a pure substance or if it's a mixture like being dissolved in water. So we mark that in a different way. We say that that is aqueous, aqueous, like aqua, AQ. And that means dissolved in water. Dissolved in water, aqueous. We can look at an example of these, and you will have practice identifying the states of matter of different chemical reactions, or chemical species, really. So let's see, what do we have here? I see, in this chemical equation, I see an S. Remember what that means? That means that this is a solid. So whatever magnesium looks like as a solid, that's what I should be seeing before this reaction takes place. Next, I see oxygen as a gas. So oxygen, gas, before this reaction takes place. This arrow tells me there's some kind of reaction happening. Reaction. So I should be seeing something. And a new substance forms, magnesium oxide in this case. And it's really nice that I have these labels here, because I know that I should get a solid out of this chemical reaction. There shouldn't be any gas, there should be no liquid, it should just be a solid only. That's really helpful when you're doing experiments or doing real chemistry, because if I was doing this experiment and I saw some bubbles, something went wrong. I didn't do the reaction I thought, because I should only have a solid. We can do the same thing for other chemical reactions. We can identify their state. In this one, I have everything aqueous in the reactants. So my reactants are all in water, dissolved in water. My reaction happens, I have this arrow, I should see something, some kind of sign that a reaction has occurred, and one of those signs can be, look, one of the products is a solid, so I should see a solid form. Somehow, some way, after this reaction happens, I should have a solid. Now that's not the only product, I also have something that is still dissolved in water. So if I do this reaction, I should see some kind of solid and some other substance that looks like a liquid. It's dissolved in water. That brings us to, how do we know if a chemical reaction has taken place? We're actually going to look for 3 different signs, and we've talked about them already in this video. One of those signs is bubbles. Bubbles. This tells us a gas has formed. Formation of a gas. Another is a solid forms. There's a fancy word for that. It is called a precipitate. 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 If you remember from your elementary or middle school science, we call rain or snow precipitation. So this is similar to that, precipitate. Something, some solid is forming. You can see that in this test tube, it looks cloudy. It's no longer clear. The last type is a color change. A color change. This is an indication of a chemical reaction. Colors change when something new has formed or maybe something has broken down. Let's do some practice now that we know what chemical reactions are and what their equations look like. Can we identify the different parts of a chemical equation? In this practice, we're going to be identifying first the reactants versus the products. Let's highlight or circle all of the reactants. Remember, reactants occur before that arrow. They occur before the reaction takes place. They're the things that are going to change into something new. So I'm, in this first example, going to highlight these reactants. How do I know that they're reactants? Well, I see the arrow. It's everything before the arrow. These are definitely reactants. We can do the same thing to identify products. Products occur after the reaction takes place. It's what is new. It's what has formed. So we see this arrow. Everything after the arrow must be products. The last piece are the states of matter. The states of matter, they're super important, especially when we're doing real experiments. We need to know, what are we looking for? Am I looking for a solid? Am I looking for a gas? So let's highlight all the states of matter. Here we are. You're looking for those parentheses. So there's a parentheses with an S. I know that's a solid. Parentheses with an AQ, that's aqueous or in water. Now this part, look, I see a parentheses, but it doesn't have S, L, G, or AQ. So that's not actually a state of matter. That is part of one of those products. But here it is, there's AQ telling me that whatever that thing is, whatever that product is, it is aqueous, it is in water. And our last one in this chemical equation is a solid. Now you might notice this second problem, wait a second, it doesn't have any states of matter. That's actually okay. Sometimes we write chemical equations or chemical reactions without those states of matter, and that's okay too. It's just extra information to convey that's really useful if you're doing real chemistry or experiments. But sometimes we're just staying in the theoretical realm. We're just talking about a reaction for another purpose, and we don't really need to know what state of matter these reactants and products are in. So this is okay too.